Hello and welcome to this edition of Turf Core Concepts. This video will continue our discussion on the benefits of aerification with compaction relief. First, let's define soil compaction. Soil compaction is a soil physical condition where high traffic reduces pore space and oxygen levels. Reduced pore space and oxygen levels results in weakened grass plants and a thinning turf. In this diagram, we see an uncompacted soil compared to a compacted soil. The soil on the right has limited pore space for gas exchange, poor water infiltration, and a compromised root system. These factors result in a weak plant. Conversely, the soil on the left has ample pore space for gas exchange, water infiltration, and root growth. All of these characteristics produce a favorable growth environment for the turf. Let's take a closer look at porosity. Porosity, which is synonymous with pore space, refers to the volume of soil voids that can be filled by water and/or air. Loose, porous soils have lower bulk densities and greater porosities than tightly packed soils. This diagram shows porosity increasing from left to right. On the left, we see a compacted, non-porous soil profile. Then in the middle is a porous but non-permeable soil. So water and soil air can be stored, however, they will not readily move through the soil profile. Last, on the right, a porous and permeable soil. In this soil, water and soil gas move freely about the soil profile. Another important term with respect to porosity is effective porosity, which is that portion of the total void space of a porous material that is capable of transmitting fluid. Porosity varies by soil texture, and effective porosity is essentially the measure of the connectedness of that pore space. So if we look at sand versus clay, we see that clay has greater porosity, but lower effective porosity, where the pore spaces are not connected. So the middle profile in figure 2 is likely a soil with high clay content where there is available pore space for water and gas to be stored. However, water and gas will not move readily. Sand, on the other hand, has lower porosity than clay, but a higher effective porosity, meaning water and gas will infiltrate and move readily through the soil profile. Now, how can compaction be managed? Dispersing traffic is a great way to manage compaction. Using cart signs and other markings, such as rope fences, disperses traffic across an area. Additionally, changing hole locations on putting greens and tee marker positions on tee boxes varies the traffic pattern on fine turf areas. Despite these efforts, compaction persists. Top dressing and filling core aerification holes with sand, a material that is not readily compacted, is an effective, albeit expensive, means of relieving soil compaction. Dispersing traffic is a preventative measure. Cultivation is the primary remedy for soil compaction. In agriculture, cultivation refers to tilling the soil. This is not possible for an established stand of turfgrass. In turf management, cultivation refers to a variety of mechanical processes that are used to loosen the soil and reduce compaction, reduce thatch, or groom the surface. Core aerification is the most effective practice to reduce soil compaction. Removal of the core helps loosen the soil in the vicinity of the core and improves gas exchange, water infiltration, and root growth. The take-home message from this video is soil compaction reduces the pore space in the soil. Pore space is crucial for gas exchange and water infiltration. For a stand of turf, the most effective method of cultivation is core aerification. Efficacy is increased when the aerification holes are filled with a compaction-resistant material such as sand. These resources were used in the production of this video. They are listed in the description of this video. This has been Turf Core Concepts. Thank you for watching.